Picture this. It's 2035. A Starship just landed on Mars. Scientists have spent 2 years collecting hundreds of terabytes of data. Video, sensor readings, 3D maps, maybe even signs of life. So how do they send it home? Not through space via radio waves. They pack it onto SSDs, load it on the next Starship back to Earth, and wait. And here's the wild part. That's actually faster. Sending a box of hard drives on a 6-month rocket trip is genuinely mathematically quicker than transmitting the same data wirelessly. Today, we're breaking down exactly why, using real numbers, and what it tells us about the future of Earth-Mars communication. Why can't we just beam the data home? 2 reasons. Reason number 1, the delay. Radio waves travel at the speed of light, but Mars is 56 to 400 million kilometers away, depending on where the planets are. That means a one-way signal takes 3 to 22 minutes. A simple back-and-forth exchange? Up to 44 minutes. And when the sun sits between the 2 planets, communication cuts out almost entirely for weeks. Reason number 2, bandwidth. NASA's Deep Space Network, giant dish antennas shared across dozens of missions, can push data at a maximum of about 5.2 megabits per second from Mars. That's early 2000s home internet. At that speed, one high-resolution image takes 1.5 hours to send. The full onboard data recorder takes 7.5 hours. NASA's new laser-based system, Deep Space Optical Communications, has already hit 267 megabits per second from deep space, and could eventually reach 1 gigabit per second. Impressive. But as we're about to show you, still nowhere near enough when you're moving terabytes. Say a Mars base has 1 petabyte of data to send home, 1,000 terabytes of surveys, climate data, research, and video footage. Option A, laser transmission. Using NASA's best future laser system at a generous 1 gigabit per second. Still a target, not today's reality. Transferring 1 petabyte takes about 92 days of non-stop, perfect transmission. In practice, with limited connection windows and solar interference, you're looking at well over a year. Option B, stuff it on a Starship. Future mission spec SSDs could hold 100 terabytes each. To carry 1 petabyte, you need 10 drives, each the size of a thick paperback, together weighing maybe 5 kilograms. Starship carries 100,000 kilograms to Mars. Those drives are a rounding error. Travel time? A standard Mars transfer takes about 7 months. Faster trajectories could cut that to 90 days. Either way, the physical drive wins, by a lot. There's a concept in computing called sneakernet. The idea that it's sometimes faster to physically carry a hard drive than transmit the same data over a network. On Earth, it's a joke. In interplanetary space, it's just math. Amazon Web Services even sells a real product called Snowball, a ruggedized storage box you ship physically when uploading over the internet would take too long. A Starship full of SSDs is just the interplanetary version of that. So, what's doing the carrying? Starship is the largest rocket ever built, 120 meters tall, bigger than the Statue of Liberty. It carries up to 100 to 150 metric tons of cargo, and it's designed specifically for Mars. Using efficient trajectories, the trip takes 6 to 9 months. Special orbital paths could cut that to around 90 to 100 days. Here's the key point. The cargo doesn't care what's in it. Whether Starship is hauling food, equipment, or a box of SSDs, it's going to Mars anyway. The drives are essentially free riders, adding almost nothing to mission cost. SpaceX plans to send missions every 26 months when Earth and Mars align. By the 2028 to 2029 window, they plan to send around 20 Starships. Each one returning to Earth could carry SSDs packed with Martian data. Load just 100 kilograms of dedicated storage, 0.1% of payload capacity, at 100 terabytes per kilogram, and a single return trip delivers 10 petabytes of data. That would take decades to transmit wirelessly, even with the most advanced laser systems we can imagine today. This idea isn't new, it just scales. On Earth, Amazon, Google, and Microsoft already do this. When you need to move an exabyte of data between data centers, putting it on trucks is genuinely faster than fiber optic cables. In space, the physics make the advantage even more extreme. Radio and lasers are perfect for real-time communication, conversations, commands, emergencies. You can't wait 7 months to tell someone on Mars there's a life support problem. But for bulk data, the kind scientists can wait for, physical winds at scale, and Mars will generate a lot of it. Drone and rover video, seismic sensor readings, genomic data if biology is ever found, full surface maps, years of atmospheric readings. None of that needs to arrive instantly. It just needs to arrive reliably and in bulk. For that, a Starship is the best data carrier in the solar system. As humanity expands to Mars, we'll likely develop a 2-track communication system. Track 1, real-time, low volume. Radio and lasers handle urgent stuff. Voice calls, commands, emergencies, status updates. The phone line to Mars. Track 2, bulk physical transfer. Every Starship making the round trip carries storage both ways. Petabytes of scientific data, software updates, medical records, research databases. The Postal Service to Mars, with the 7-month delivery window. NASA is already planning for this. The concept of delay-tolerant networking acknowledges that deep space communication will never work like Earth's internet. Data has to be stored and forwarded in chunks, not streamed in real time. And ironically, the most advanced rocket ever built might become the most important data pipeline between 2 planets. Not because of any antenna on board, but because of the drive sitting in its cargo bay. There's something poetic about this. We've built the most advanced communication technology humanity has ever seen. And the best way to move massive amounts of data across the solar system is still to put it in a box and fly it there. Distance is distance. Sometimes the answer isn't a faster signal, it's a smarter package. Starship was built to move people and supplies to Mars, but it may turn out to be just as important as the solar system's first interplanetary data courier, one SSD at a time. If you found this interesting, you'll love our next video, breaking down what a full Mars colony's communication network looks like in 2040, and why Musk wants a Martian version of Starlink. Hit subscribe so you don't miss it.